So in this video, we're going to look at an improper integral that has an infinite limit of integration as well as a discontinuity. So here we have the integral from 0 to infinity of 1 over x squared dx. And we want to notice that we have an infinite limit of integration, but we also have a discontinuity because on the interval from 0 to infinity, 1 over x squared is undefined when x equals 0. 1 over 0 squared would be undefined. So we have to deal with this by breaking it into two pieces. And usually what you do is you pick a number somewhere on the interior of this interval. It doesn't matter where. And you look at it as being the interval from 0 to some intermediate value, let's say 1. And then union with the interval from 1 to infinity. This number here, as long as your function's defined at that number, it's golden to use it. So here's how we do this. We're going to take the limit as a goes to 0, and the only way to get to 0 here is to go at it from the positive side. So we're going to do the limit as a goes to 0 from the positive side of the interval from, replace the 0 with the a, and run to any number. I'm choosing 1, for which 1 over x squared is defined. So the limit as a goes to 0 from a to 1 of 1 over x squared dx. And then you go plus, and then you pick right up at that 1 on the second interval. You pick right up at that 1 and you run to b, or whatever your favorite variable name is, run from 1 to b, and take the limit as b goes to infinity. And this is going to be 1 over x squared dx. And then you attack the two separately. So we take the limit as a goes to 0 from the positive side. We integrate this. We get negative 1 over x running from a to 1. Plus, we get the limit as b goes to infinity of negative 1 over x running from 1 to b, and then we just grind it out. We plug in the limits of integration. So we have the limit as a goes to 0 from the positive side of negative 1 over 1 minus negative 1 over a plus the limit as b goes to infinity of negative 1 over b minus negative 1 over 1, which is just going to simplify to plus 1. And this will simplify right here to negative 1 equals, and the limit of a constant is the constant. Double negation makes this a plus. So we have plus, the limit of a constant is a constant, and then the limit as a goes to 0 from the positive side of 1 over a still needs to be evaluated, plus the limit as b goes to infinity of this. We can actually evaluate this. The limit as b goes to infinity of this will be negative 1 over something getting infinitely large is 0, so we get 0 plus 1 is 1. Negative 1 plus 1 is 0. So we just have the limit as a goes to 0 from the positive side of 1 over a to deal with. And as a goes to 0, as the denominator goes to 0, 1 over something going to 0 is going to go to infinity. So this is an integral that diverges or does not exist. It diverges. You got to spell diverges right, though. It diverges to infinity.